So, dear participants, let's start the first session named Climbing Robots. And the first speaker is the author of an article entitled A Four-Legged Climbing Robot on a Fragile Cylinder. Please introduce yourself.
Hello, I am Melkumova Elena Vadimovna from Moscow State University, and my report with Professor Yury Filipovich Golubev from Keldysh Institute of Applied Mathematics and Moscow State University. We are from Moscow, Russia, and we want to speak about prescribed motion of a walking robot on a roof fragile cylinder. For the first, we invite all our colleagues to participate in our seminars in MSU, which usually on Monday at 18 and 30 o'clock, and who want can write on, for example, my email. We consider the walking robot on n legs. Each leg contacts the surface on one foothold. Suppose that robot legs accomplish a desired motion about of robot body. Robot motion is described by general dynamic theorems. The momentum and angular momentum theorems gives 6 differential motion equation. When the robot has 4 legs, then the problem of solution existence is reduced to inequalities system analysis. Classification of foothold's position is formed in dependence on the friction coefficient done by computer analysis. On the picture, we can see footholds and normal and the reactions. Usually the phi force is, for example, is weight. We want to say that this problem is very similar to grip, and there are many analogies with this problem. Let's see. For example, if we have 2 legs that we solve the system and we have the reaction in the first leg, in the second leg, and for example, in the fingers. And we can demonstrate this problem in a very special form. For example, I have a pen and I show that our problem is very similar to the problem of oscillation of a cylinder, for example, on 1 point. So, for example, for 2 points for holes, we can show that our analytic research gives such graphics. So inequalities are, we have square inequalities and coefficient about square is the same. So on the picture, we see that when it coefficient less than 0, the solution existence exists, and in when E coefficient is bigger than 0, we have to give special analytic research and have a special graphic. Two lines means that we hold the cylinder by in 2 points on one diameter, and determinants d more than 0. So for example, if the inclining is 45 or p divided 4, red means that theoretical researches and analytical gives the same result, that the solution is exist. In the area when we don't know, the blue one show where it is exist. So this work was supported by the Russian Foundation for Basic Research, and we can show, for example, that if we have, for example, a ring, we can touch it by hand in, for example, one geometrical points, but we have two fingers. So it's very interesting that in different problems we have many analogies, and let's see that on this slide, we see that this solution is only for horizontal cylinder. If cylinder is not horizontal, we have another the same part, and it cannot be solved analytical. So we use a computer simulation. And it is interesting that in two hot-hold phase, the point C, for example, it is center mass, and the reactions have to be in one plane parallel to force phi or the weight. And so for 4 legs or 4 fingers, we can solve the problem such that it divided to 2 parts. And maybe a question, and I speak something more about something in this problem.
So do you finish?
If there is no question, I can speak more about this problem. The reaction searching problem is similar to reaction distribution for whole problem for inhomogeneous gravity field, as I said. When mentioned footholds are on the external surface of roof inclined cylinder, which axis has an angle with vertical vector. This work developed investigation of academician Dmitry Evgenich Hatsymsky. It's our school, and from the life go unfortunately Pavlovsky Vladimir Evgenich. He was in our seminar organizer, and now seminar which we invited our colleges in MSU to hear their reports, have chairs Golubev Yury Filipovich, me, and Claudia Evgeny Kimova. It's a department theoretical mechanics and mechatronics in MSU, where I give lectures and seminars in another faculty of computing science as a lecturer, and on both in mechanical mathematics as a seminars. What about time? 5 minutes?
You have 5 minutes for questions.
Question. So if questions no, I may speak, or how you said me?
Dear participants, is anyone have a question?
So I can show that 2 points on one diameters on the ring, and if the fingers in the ring, we can say something. And that is very interesting, that many problems are solved without inequalities, because usually it's very difficult, and people use analyticals and not to want to know if the robot stay on some surface or not. For example, if we stay on the floor horizontal, the center mass had to be the projection in the supporting points figure. And for example, our problem, if we have a floor and the seal, 2 planes, so the center mass, for example, for 2 points, have not to be in supporting line between this point. So it is a very interesting problem, and our inequalities, they are well for different surfaces. So to go on surface or to hold the surface, it's very same problems. What time?
You have 3 minutes, and I would ask a question to you. I would like to ask, what type of boundary conditions for such tasks do you can you name?
Boundary conditions, you means that if we have inequalities of equilibrium, we have only quick equation. And if, for example, we see normal reaction had to be more than 0 or less than 0, because what is normal reaction? It's on the normal to the surface projection, and we have Amonton Coulomb friction, and when it stay, it's 1. When it's move a little, it's the same too. But people sometimes solve the problem, but not really see this reaction. And for example, some robot maybe fall, but they don't said that it's okay. For example, if a car go by right and it may be fall, but people said no problem, it's maybe go too slow.
Okay, thank you. Let's thank the speaker and move on to the next one.